we're looking at how to factor or a review on how to factor. Chapter 9, Topic 1. So to begin, start every problem you should begin trying to factor out the GCF, the greatest common factor, between the terms. So in this case, the easiest way to do this is to check the GCF of the numbers and then check the GCF of the variables. So for the numbers, we're looking at 2, 6, and 12. So the GCF of those is going to be 2. And then for the variables, x cubed, x squared, and x, the GCF is going to be the one with the lowest exponent. So in this case, x. So we're going to factor out the 2x from each of these. So we're going to have to look at each of them and see what we're left with when the 2x comes out. So essentially, we're going to be taking 2x out of each of these. So for the first one, 2 comes out of 2, leaving 1. X cubed, bring out an x, you're left with x squared. For the next term, 6 over 2, that's 3. And then x squared with divided by x, it just leaves you with an x. For the last term, it's negative because of negative 12, and 12 divided by 2 is 6, and the x's would cancel. So this is what we'd be left with when we take out the GCF, 2x. Number 2, you have to remember that when the first term is negative, you take out a negative number, okay? The first term is not allowed to be negative. So in this case, the first term is negative 5. So that tells us that we're going to have to factor out a negative number. So we'll take a look here and see what the GCF is. So 5 and 15, that's a GCF of 5. X to the 5th and x to the 3rd, the smallest one is x to the 3rd. So we're going to take a negative 5x cubed out of both of these. So negative 5 out of negative 5 cancels. X to the 5th, taking out x cubed, you're left with x squared. Okay, 5 minus 3 leaves you with x squared with 2 x's. For the next term, it's actually going to be negative because dividing this positive number by a negative changes it negative. And 15 divided by 5 is 3, and the x's are gone because this is x cubed and so is this. So we are left with negative 5x cubed and x squared minus 3 as our two factors. Next, we want to look at how to factor trinomials. All right, so the key to factoring these is to factor by grouping. So in the top here is a times c. So in this case, 1 times negative 12 is negative 12. And the bottom here is b, so that's negative 1. We're looking for numbers that multiply to negative 12 and add to negative 1. That's negative 4, positive 3. Now what this allows me to do is to split this middle term. So the rest stays the same, x squared, except now the negative x becomes negative 4x, positive 3x, and then the rest of the problem stays the same. So I can now group together the first two and group together the second two and factor out the GCF for each of these. So for the first group, I can factor out an x, leaving x minus 4. For the second group, I can factor out a 3, leaving x minus 4. So that tells me that my two factors, one of my factors is x minus 4, this thing that shows up twice, and the other factor is the GCFs, x and positive 3. Now you'll notice that there's actually kind of a shortcut here when the a value is 1, because you see there's no number in front of the x squared here. And there's actually a shortcut that we can use for these types of problem when there's nothing in front of the x squared. Okay, because you'll notice my factors, both of them start with x. This factor starts with x and this factor starts with x. And what comes after them are just the numbers I had in the x, the negative 4 and the positive 3. And as long as there's nothing in front of this x squared, then that's going to work out that way. So if we look at the next one, I can do the next one that way. Okay, so in the top is positive 6, and the bottom is positive 5. Two numbers that multiply to 6 and add to 5 are 3 and 2. However, I don't have to go through the whole process, because like I said, we can just follow the pattern. So both factors will start with x, because there's nothing in front of the x squared. And then I can just use these two numbers to fill in the rest. So plus 3 and plus 2. So my two factors would be x plus 3 and x plus 2. However, this shortcut does not work if there's a number in front of the x squared. Like in number 5 and number 6, we have a number in front of the x squared, so that shortcut does not work, and we do have to actually do it the long way. So in the top, a times c, negative 15, and the bottom is b, negative 2. Numbers that multiply to negative 15 and add to negative 2 are negative 5 and positive 3. And now I do actually have to go through the whole process for this one. So I'm going to break up negative 2x squared into negative 5x and positive 3x. And the rest of the problem stays the same. Okay, group these two, take out the GCF. So the GCF of the first group is x, leaving us with 3x minus 5. GCF of the second group is just 1, because they don't have anything in common, leaving us with 3x minus 5. Okay, so that means my two factors, one of them is 3x minus 5, and the other one is x plus 1. Same thing with number 6. I still have to go through number 6 the long way. 2 times 5, that's positive 10, and then positive 11 in the bottom. So numbers that multiply to 10 and add to 11 are positive 10 and positive 1. So I'm going to use those two numbers to split this middle term into 10x and 1x. Okay, doing this, I can group together my terms. So here we go. And then factor out the GCF from each of these groups. So the first group has a GCF of 2x, leaving me with x plus 5. The second group has a GCF of 1, leaving me with x plus 5. So my two factors, one of them is the number, that factor that shows up twice, x plus 5, and the other one is my GCFs, 2x and positive 1, so 2x plus 1. So my factors for number 6, x plus 5, and 2x plus 1. Now, another type of factoring pattern that we need to be able to recognize is a difference of two squares. We looked at this when we were factoring, but a difference of two squares is factored in a very specific way. If you have a square minus another square, then they can factor into the sum and difference of what makes up the two squares. So if you can find out what makes up these two squares, you add them for the first factor, subtract them for the other factor. So for instance, and sometimes it's nice to put parentheses around it so you can see what makes up each square. So like for this one is a square made up of x times x. X to the second power would make x squared. And 9 is a square made up of 3 times 3. 3 to the second power is 9. So once you have these two, in this case x and 3, then you can factor it because one of the factors would be plus, so x plus 3, and the other factor would be minus, so my x minus 3. As long as you can find the two factors, the two squares, then you're good here. So for number 8, we need to figure out how to make this a square. Well, 4 is made a square by 2. 2 times 2 is 4. And x to the second is made a square by x. X times x is x squared. For 25, 25 is made a square by 5. So 2x and 5 are what makes these squares. So the first factor would be them added together, 2x plus 5, and the second factor would be subtracted, 2x minus 5. Now with some problems you do have to use more than one method to try to factor them. So like most of the time this just means factoring out the GCF before you do anything else. Okay, so for example, number 9, we can't factor number 9 yet because there's a GCF that needs to be factored first. So before we try to factor number 9, we first factor out the GCF. Now even though they don't have a number in common, they do have a variable in common. X cubed, x squared, and x, they all have an x in common. Not only that, but the first term is negative, so we need to factor out a negative GCF. So even though x is the GCF, I'm going to factor out a negative x. So negative x comes out, which means each of these negative x should get divided out of it. So if you divide a negative out of these, it'll just change their signs. So x cubed over x leaves x squared. 7x squared over x just leaves positive 7x because an x comes out and the sign on the 7 just changes. And then 12x divided by an x is just going to leave us with a 12. So I take out the negative x, and when I do, I'm left with x squared plus 7x plus 12. Now the issue is that this can be factored further. Okay, this polynomial can be factored again. So what we want to do is we want to split this into its two factors. So positive 12, positive 7. And we can use the shortcut on this one because there's no number in front of the x squared. So I know both my factors here will start with x. So the numbers I'm looking for need to multiply to 12 and add to 7. So that's positive 4 and positive 3. So one of my factors will be x plus 4. The other one will be x plus 3. And there is my factored form for number 9. Negative x, x plus 4, x plus 3. Number 10, 2x cubed and negative 8x. So we have to take out the GCF here. For the numbers 2 and 8, the GCF is 2. For the variables x cubed and x, you can take out an x. So I'm going to take 2x out of both of these. So 2 out of 2, x cubed and x, so you leave with x squared, and then minus 8 divided by 2 is 4, and x over x cancels, so x squared minus 4. Now we took out the GCF, but you'll notice here x squared minus 4, this is a difference of two perfect squares. X to the second and 2 to the second. So that can be factored by a difference of two perfect squares. So one of the factors would be x plus 2, and one of the factors would be x minus 2. And that's our factored form for number 10. So we took out the GCF, and then we factored it further. Number 11, once again, these all three have a GCF. They don't have a variable with the GCF, but they do have a number because it's 6, 16, and 8. So 2 goes into all of those. So I'm going to take out a 2. So taking out a 2 leaves us with 3x squared minus 8x plus 4. Now this polynomial, 3x squared minus 8x plus 4, that can be factored further. So I do have to do this the long way because there's a number in front of the x squared. So I do have to do this the long way. So 3 times 4, so up in the top is positive 12, negative 8 in the bottom. Looking for numbers that multiply to positive 12 and add to negative 8, that's negative 6 and negative 2. So I'm going to use that to break up the negative 8x. So it becomes negative 6x and negative 2x. And then I'm going to factor the GCF out of each group here. So the first group has a GCF of 3x, and that leaves me with x minus 2. The second group has a GCF of negative 2, because the first term is negative. So that also leaves me with x minus 2. So the first factor, 3x minus 2, and the other one is x minus 2. So going back to the original problem, remember I took out that 2 to begin with. So 2 is a factor, 3x minus 2 is a factor, and x minus 2 is a factor. So these are the three factors for number 11 here. 2, 3x minus 2, and x minus 2.